So let's start from best effort broadcast. So best effort broadcast is the simplest to implement and also provides the lowest degree of reliability. It is basically similar to the one that we just discussed in the example, basically iterated unicast. So let's look at the specification. So best effort broadcast, or BEB as we will shorten it, supports two external events. So the broadcast requests are passed via this broadcast primitive, and this represents the request to broadcast message M to all processes, and the indication event will be deliver. Okay, so deliver has two attributes. One is the message being delivered, and the other one is the source process for this message. The source means that it is the sender of M. Okay, and best effort broadcast supports three properties that we call BEB1, BEB2, and BEB3, and they are as follows. Okay, so the first property is the one which is most interesting, and it is called validity. And intuitively, validity property says that all processes deliver a message unless its sender has crashed. Okay, so more formally it says that if a correct process broadcasts a message M, then every correct process eventually delivers M. Okay, so notice what happens here. So we have as a premise that a correct process broadcasts a message. Okay, so in this case, if the sender is correct, then this must happen. So every correct process must eventually deliver M. But if the premise is false, then of course anything is possible, which means that some processes may deliver M and others may not deliver M, either correct or faulty, does not matter. Okay, so this is the most interesting property of best effort broadcast, or BEB. And then the next two properties are just simple properties that you would normally expect from any communication service, from any reliable communication service. So the next one is called no duplication, and we have already discussed no duplication in other contexts in this class. So basically what it says is that no message is delivered more than once by the same process. And the next property is called no creation, and it says that if a process delivers a message with the sender attribute being equal S, then this message was actually previously broadcast by S. Okay, so again, this is a very natural thing to expect from a broadcast service. So basically it says that messages can't be created out of thin air. Okay, so let's see a few examples of what could happen if we have this BEB, best effort broadcast primitive. So in our examples, we'll be using this type of diagrams, as you see on this slide. So these diagrams are called process time diagrams. So we basically have, for each process, we have a timeline, a separate timeline. Okay, so these separate timelines for each process basically designate the concurrent execution of the processes. And then events can occur at different processes, and we will indicate the event occurrence with a dot, and then we will write the name of the and attributes of the specific event that is associated with that dot. Now we'll have failures in these examples, and we will indicate failures with red crosses. So here this red cross basically shows that this message is lost. This message being sent by P1 is lost before it reaches P3. Okay, so what happens in this example is that process P1 is correct. How do we know it is correct? Because we don't have a red cross on its timeline. So whenever we have a red cross, it means on the timeline, it means that process crashes. Okay, so P1 broadcasts message M and P1 is correct, and then P2 delivers M and P4 delivers M, but P3 does not deliver M, and actually P1 also does not deliver M. And the question is if this behavior is allowed by the BEB specification. Let's take a second to think about it, and the answer is, of course, no. This behavior is not allowed because the validity property requires that every message broadcast by a correct process is delivered by all the correct processes. And all processes in this example are correct because we don't have any red crosses on their timelines. And therefore, it is not allowed for a message not to be delivered by some of the processes, like P3 and P1. So let's consider an example in which P1 crashes. So P1 crashes, and as a result, M is not delivered by P3, but it is delivered by P2 and P4. And the question is if this is allowed, and the answer is yes, this is allowed, because validity only requires a message to be delivered if the sender is correct. And in this case, P1 is not correct, and therefore its message may be delivered by some processes and not delivered by others. Okay, so we can have this kind of situation.